Hi, Alex from LPEpower here, and welcome to the show where we discuss how to translate car technology from real life into Lego. Today I will show you what is wrong with the unimog front suspension and how to fix it. Let's begin by analyzing the problems. In our previous suspension videos, we have discussed how a proper suspension has to be designed and its effects on the steering behavior. The unimog does all of these things wrong. First, the caster. As you can see, the caster is negative, which has a destabilizing effect on the vehicle. When it goes straight ahead, it tends to go its own way as soon as the surface isn't absolutely flat. More on that in a bit. The second thing is the pivot point of the wheels, which is very close to the center of the car instead of the center of the wheels. This creates a large lever on which the road can act and makes the car hard to control. In addition to that, the wheels move around in the wheel wells too much and take up a lot of space while pivoting. This greatly increases the forces necessary to steer the car. The third fault is that the steering of the unimog is extremely hard to turn and requires a lot of force. You can literally hear the parts scream for mercy. This effect is enhanced by the two additional steering links that link each wheel hub together and are pinned with friction pins. Even when the vehicle is on its side, like in this video, it is hard to turn and the gear on the steering rack is under so much pressure that it had enough and decided to quit. So the combined effect is this. A lot of force is required to steer the car, which makes you absolutely powerless when it needs to negotiate any kind of obstacle. As soon as a wheel hits any kind of imperfection in the surface, it will deflect to that side and there is absolutely nothing you can do about it. I have tried to anticipate this and applied force to the steering in the opposite direction, but the wheel deflected anyway and stayed there, because the suspension geometry is all wrong. It does not return to the straight ahead position. All this makes the unimog, which is otherwise a great model, not very fun to play with. If you own one, this is no news to you. So I decided to correct this, and here is how. First, you can find the building instructions for this new suspension in the link in the description, all packed in a convenient zip file. So, the caster. The new LPEpower suspension has of course a slight positive caster, as it should be. In the corner, just a quick reminder how it was before. Secondly, the pivot point. For this, we need a kingpin inclination. I have removed bits of the car here and a spring for a better view. The kingpin axis goes from the top pivot, which is now angled, through the CV joint instead of the universal joint that Lego used, and down to the edge of the tire. If we compare this with the Lego solution, we see that in the Lego suspension the pivot is vertical and it goes through the universal joint and meets the ground about 3 studs away from the wheel. This is not a very good solution. If you look at it from the bottom, the comparison is even more striking. As you can see here, I have used a double pivot approach here to move the lower pivot to the correct position where it is impossible to mount a normal pivot. In comparison to the Lego suspension, we see that the pivots are now on the inner edge of the wheels. Because of that, the lever that the road can act on the wheel is much smaller. In fact, the lever of the steering is now bigger than the lever of the road. All while in the Lego suspension, the lever of the road was much larger than the lever of the steering. And of course, the steering in our new suspension uses only one steering rack, which slides smoothly and requires little force to turn. Because of that, I was even able to retire the knob gears, which were required before, and I installed thin 20-tooth gears instead, which give you precise control over the steering. And while I was at it, I also replaced the short panel rod with a longer one, which reduces the amount of sideway movement of the suspension while it travels up and down. Okay, so when we see the new setup in motion, we see that it goes very light. When driving over any kind of obstacle, it is pretty unimpressed of the bumps, and although we can observe a small deflection of the wheel at the initial contact, the wheel immediately straightens itself again, because of the correct geometry, which forces the wheels to point straight ahead at all times, just like in a real thing. I have driven it repeatedly over my hand and a 2.5-inch laptop hard drive, just to demonstrate its straight line stability in uneven terrain. You have total control of the direction in which the car is going. It is easy to steer and requires little force to do so. Because of that, it is also easy to motorize even with a motor sitting in the cab. When viewed from below, we see the double pivots in action and how they move the actual pivot point to about where the gears are in the wheel hub. Because the steering axis is inclined, the actual pivot of the suspension is of course at the edge of the wheel, about where my finger is. For comparison, see how they look side to side. Notice how much effort one has to invest into moving the Lego version, and how jerky it is because of that. So in conclusion, I understand why Lego did the suspension how they did it. It is simple and cheap to make, because it uses very few simple parts, but they could have done much better. I have come up with this in a week with a few hours of build time, so it could surely be done much better. I am slowly tired of those overly simplistic Lego suspensions, because they teach the kids the wrong things about suspensions and they are getting very boring. So that's all for today. Remember to check the building instructions in the links below this video, and don't forget to click the like button. Next time we take a look at my favorite front suspension setup, the Mcpherson Strut suspension. I'll see you next time.